This is the sixth in a series of videos where we're looking at NetQoS, providing an introduction to NetQoS. We're looking at some of the capabilities of the Network Performance Center dashboard and some of its key components, and we're providing visibility into some of the benefits that the NetQoS technology will provide. In the first video we talked about Network Performance Center and how it can be one place for troubleshooting of application performance problems, as seen particularly by end users. The second video we talked about how the NPC was easy to configure and able to be tailored without the need for programming in order to provide the right information to the right people at the right time, whether you're senior people or potentially just resolver groups or particular operators. In the next video we talked about application delivery analysis and how that can be a particular place that where we can have a look at end-to-end health of applications. We can look at sort of how the application itself is performing, right down to very detailed metrics at the TCP level, and providing visibility into where the application's failing potentially and where end users are being affected as a result of that failure. Then we looked at WAS acceleration, and we looked at the Cisco use case where we're grabbing information from Cisco as well as using our application delivery analysis agent, which is embedded in the WAS appliance. And we also looked at unified comms. The next component we're going to look at is around application usage. And application usage obviously takes two use cases. The first is around what's happening over the potentially last hour, last 12 hours, last 24 hours, or potentially what's happening over the last 6, 12, 18 months. Or if you're rolling out a new application, what we want to predict that's likely to look like over the next little while. What we're looking at here in this dashboard is an application dashboard looking at potentially a rollout, potentially a pilot, and seeing how it's actually running as compared to and as seen by the end users. We can see here that over this time horizon we're actually using application delivery analysis to actually look at the application itself, and when we see 125,000 observations, what we're looking at there is the number of requests from clients, whether we're talking about servers, in-user PCs, whether we're talking about iPads or Androids, and we're seeing the response time back from the server. And we can see for this particular server, we can see that where it's green, that's normal behavior, and yellow, degraded performance and excessive performance. So there's likely to be a problem with this application rollout that we might want to drill down into further details. Normally, as a headline dashboard, we'll grab information that makes sense as part of this application. So we might grab information from the infrastructure layer, maybe top CPUs for each of the servers that comprise the service. We might want to also look at the server response time as an average for this time horizon or this period. We might also want to have a look at the top utilization maybe of the network in and out, or maybe the top utilization of the network interface cards on the servers. We might also want to have a look at the stacked protocol from a net flow perspective of what's happening on the network at the same time as we're rolling out an application. Particularly useful if we're talking about an application which uses lots of network. We might want to understand what the impact is of potentially our other HTTP applications, or maybe our Oracle servers, etc. Seeing all this information in one place at one time will help with troubleshooting. In order to troubleshoot what's going on here with this particular application, we might want to, as in the first instance, go and have a look at the server itself. And we can see here, looking at the server itself from an infrastructure perspective, we can see here that the CPU at this moment in time is running at between 60 and 70%. So, high utilization. And we might also want to have a look at the trend details. We can see the trend details. At the same time the performance is degraded for the server, as seen by the end users, we can see the server itself is pegged at 100% CPU. At the same time, we can see that there's not much the memory utilization is pretty static. And so we can conclude that with our application rollout, the reason why end users are experiencing bad performance is because the CPU is pegged. So when we've actually done our design, we didn't actually account for the CPU processing that we're currently seeing actually in production or as part of our pilot. And so therefore we can conclude that we need to either slow down our rollout or we need to increase the hardware that we're actually using as part of this rollout. Something that's often forgotten as part of rolling out new applications and seeing what's going to happen in the future is actually understanding all of the applications that are running across the network from an application usage perspective, and seeing what the top utilization for each of those applications is likely to be, and then coming to a conclusion about what we need to do with regard to maybe increasing bandwidth or increasing the server processing power. What I'm going to show you here is this is a report out of the NetFlow analysis tool, where we're looking at NetFlow or SFlow or IPFix data. And I'm going to look at baseline from the last 6 months. I might time filter on the basis of business hours. And I'm going to look at the top 75th percentile for all of these applications. And I'm going to see what that bandwidth utilization is likely to be. And for these applications, this is actually what I've done on a client network. So I've actually removed the, on the right, those are specific protocols, but you can get a glimpse. Maybe blue is HTTP, maybe F is FTP, maybe green is Exchange. But for 75th percentile, we can see for this network interface, we can see that we're utilizing 4 megabits per second. So if we're likely to roll out voice or video or other applications on this network, if we only have 4 megabits per second, I can guarantee that this new application rollout is going to fail on the basis of historical usage. However, if we're going to roll out a new application and we've chosen to upgrade our WAN links to 12 megabits per second or maybe higher, maybe that's overkill on the basis of the number of telephone calls we're anticipating across the network, and so therefore we might use this same information to save us some money.